In this video, we're going to be covering the point gradient form of a linear equation. So we use this when you're given the gradient and a point on the line. So the formula for this is y minus y1 equals m, and then in brackets, x minus x1. Alright, so we're going to do some examples using this formula because it is a very common and useful formula. So find the equation on the line given we have a point at 2, 5 and the gradient's 2. So I have a point at 2, 5 and I know my m equals 2. So I'm going to label these as x1, y1, and then I'm going to write out my formula. So y minus y1 equals m x minus x1. Alright, so now what we need to do is substitute in those values that we know. So y minus 5, because our 5 is our y1, equals 2 bracket x minus 2. Alright. Now there's multiple ways you can do this. You can use it as the general form here, or you could convert it to the y-intercept form. I'm going to do the general form, so I want to expand these brackets, and remember each one of those arrows is a multiplication, so y minus 5 equals 2x, take away 4, I can then plus the 4 to both sides, these cancel out, I get y minus 1 equals 2x, but I want the 2x to be positive, so I'm going to move everything on the left side to the other side, which means they change signs. So we get minus y plus 1, this cancels that out, I'm left with 0 equals 2x minus y plus 1. Now what I could have done up here, let's say I get to this step again, the y minus 5 equals 2x minus 4. I could leave this as the gradient intercept formula by plus 5 plus 5. Those 5's cancel out and I'm left with y equals 2x plus 1. And I can leave it as that. So either one of these, so here is my general form, here is my gradient intercept form. Both of those are fine. So here's another one that we can do. So I have -1, -2, that's my x1, y1, and m equals 2 over 3. So y minus y1 equals m bracket x minus x1. So y minus minus 2, so when we have those two minuses together like that, becomes a positive, so plus 2 equals 2 over 3 x minus minus 1 again, so the two minuses make a positive. Now what I can do here is I can multiply my 3 up here and I can get 3y plus 2 equals 2x plus 1. I can expand both those brackets, so I get 3y plus 6 equals 2x plus 2. Alright, and then I'm going to put this in the general form, so I can minus 3y minus 3y. They cancel out. I get 6 equals 2x. Take away 3y plus 2, and then minus my 6. So 0 equals 2x minus 3y minus 4, and you can leave it as that. Now the more common way of using this formula is when you're given 2 points. So the first thing we always do when we're given 2 points is rewrite them and label them. x1, y1, x2, y2. We then need to find our gradient using the gradient formula, which is m equals y2 minus y1 over x2 minus x1. So let's find this by substituting those values in. So y2 was 6 minus my y1, which is 3, and then 10 take away 7. which ends up being 3 over 3, which is 1. Alright, so now that we've got our gradient, I will go up here, and we're going to use our point formula. So y minus y1 equals mx minus x1. I'm going to stick with my x1 and y1 that I've already labeled. So now y minus 3 equals the gradient, which we said was 1, x minus 7. I don't need to expand those brackets because it's just times it by 1, so I'm left with y minus 3 equals x take away 7. This time I'm going to leave it as the gradient intercept formula. So let's plus 3 to both sides, they cancel out, and I get y equals x minus 4. Alright, so that is the most common use of this formula, and it's important to know that. So finally, to recap what we just covered, the point gradient form is used when you're given the gradient and a point, so x1, y1, and the formula is y minus y1 equals m times by, in brackets, x minus x1. And remember, sometimes you do have to find your m using your gradient formula, which is m equals y2 minus y1 over x2 minus x1. Those are very much used together.